A lag screw will be placed in the bone model perpendicular to the fracture line. Be sure to choose the end of the bone that has a simulated fracture matching the one shown on the screen. The 3.5 millimeter drill bit is placed through the appropriate end of the double drill sleeve. The glide hole is drilled through the near cortex only. This hole has the same diameter as the outer diameter of the threads of the 3.5 millimeter screw. The 2.5 millimeter end of the double drill sleeve is placed through the glide hole until it engages the far cortex. The 2.5 millimeter drill bit is passed through this end of the double drill sleeve and the thread hole is created in the far cortex. Remove the double drill sleeve. Attach the countersink to the T-handle. Countersink the glide hole in a clockwise direction. Using this instrument increases the contact interface between the bone and the screw head. The depth gauge has a rod with a hooked end and a measurement bar which is used to determine the length of the screw needed. The measurement bar is marked in 2 millimeter increments. The hooked rod is passed through both holes in the bone. It is tilted slightly and withdrawn until the hook engages the surface of the far cortex. The rounded end of the measuring device is pushed tightly against the near cortex, and the length of screw is determined from the measuring scale. Measurements are rounded up to the nearest 2 millimeter mark. The 3.5 millimeter tap is placed through the appropriate end of the double drill sleeve and passed through the glide hole until it engages the thread hole. Turning the tap cuts the thread in the thread hole. The tap should be turned until at least 2 or 3 threads have exited the far cortex. The tap is removed, and a 3.5 millimeter cortex screw of appropriate length is inserted. Compression is achieved across the fracture line as the screw is tightened. Note that the long axis of the screw is perpendicular to the long axis of the fracture line.